Okay, now we're going to look at what's called your remainder theorem. And as it states, if the polynomial f of x is divided by x minus c, then the remainder is f of c. Okay, so c is going to come from here. Like if you had, just like a while ago, if you take this, set it equal to 0, solve it, then you get c. Okay, so that's, again, why we change that sign when we're setting up synthetic division. But if you were to take this value, do your synthetic division using this value with the given polynomial, then your remainder, it would be the same thing as if you directly substituted this number into the function. Alright, so the example that we're going to use for remainder theorem, of course it specifies that you are to use synthetic division and the concept of remainder theorem to find the indicated value. Now, it's not giving you in the factor form like the x minus c. They're going ahead and telling you here your c value is 2. So when you set up your synthetic division, you don't actually change this value. The only time you do that is if it's given to you as a binomial, like x minus 2 or x plus 2. Then you do have to change the sign. Alright, so I'm setting this up with positive 2 out front. Alright, my fourth power, so coefficient of 3. I'm missing my third power. And then I've got a negative 1. And then I've got a positive 1. But I'm also missing my constant. Even if you're missing your constant, you've got to remember to put a 0. Okay, so if I run through my synthetic division, okay, I end up with a remainder of 46. So what this means is that f of 2 is equal to 46. Now, if you wanted to check this, you can just check it with direct substitution, like in your calculator. So I'll just scoot it on up here. Okay, so in your calculator, if you'll just directly substitute 2 into the polynomial, so we have 3 times 2 to the 4th power minus 2 squared plus 2. And so if you notice, there's a glare on it, if you notice the value that you end up with when you do direct substitution, see, is the same thing as your remainder. So that's the meaning of your remainder theorem. Okay, next we're going to look at what's called your factor theorem. This is where, when you're doing the synthetic division, you're specifically looking for a remainder of 0. Alright, so say this time f of c equals 0. So what we just learned, remember on the remainder theorem, like we had f of 2 is equal to 46, and 46 was our remainder. Well, this is telling us we want our remainder to be 0. So, if you get a remainder of 0, which means it divides evenly, then x minus c is called a factor. If you don't have a remainder of 0, you cannot refer to it as being a factor. Then, if you know that x minus c is a factor, then when you evaluate it, your f of c should equal 0. So basically these are just kind of reverse statements that state the same thing.